Welcome to EMEA OCI Landing Zone series. I'm Paula Juarez, an EMEA Landing Zone specialist, and my mission is to simplify the onboarding and operation of OCI. In this video, I'll explain how we can deploy the OCI landing zones that are ready for any workload using our landing zone extension assets. Specifically, we will discover the Kubernetes Landing Zone Extension, also called OKE Landing Zone Extension. Do you need to deploy your Kubernetes cluster in a secure and easy way? Let's get started. Let me start by introducing our OCI landing zone framework. Each customer is unique, whether it's the site, the industry, or the specific security standard. It's not possible to address all customer requirements with a single solution. We offer different landing zone models, including the core landing zone and the open landing zone. Both comply with the CIS benchmark security standard. Depending on the customer requirements, such as business lines, complexity, or the level of customization needed, we will recommend one over the other. Once the foundation landing zone is selected, we will be prepared to deploy a generic and a scalable landing zone. Now, what happens if we need to onboard complex workloads with specific requirements, such as Kubernetes/OKE, which typically requires 4 subnets for the control planes, load balancers, worker nodes, pods, and also specific policies? We will need to review all the requirements across all the documentation pages. The solution is simple. By using a landing zone workload extension, we can address the design and the implementation requirements for any specific workload, such as XSES, OCBS, AI, and many others. These extensions enhance our landing zone, ensuring it is fully prepared to deploy services, which help you save time and effort. Our OCI landing zone covers a collection of best practices across many layers, including security, network, and operations. To dive deeper into specific topics, we offer the add-ons, such as our hub models, sovereign controls, or subnet examples. Last but not least, one of our key strengths is that everything can be deployed in an automatic way, using a declarative approach with our public Terraform modules. For customers requiring infrastructure as code, everything can be integrated into the existing GitHub models. Additionally, customers without any Terraform skills can easily deploy everything through a graphical interface using Resource Manager and our orchestrator solution. So you need to deploy your OKE cluster and your tenancy is already prepared. What are the necessary steps? First, we need a foundation landing zone. I'm choosing the open landing zone, the 1OE model. Next, we will extend the foundation landing zone with the Kubernetes landing zone extension. As a step 1, the 1OE will create a specific compartment structure, including compartments for the shared resources and dedicated compartments for all environments. By default, the blueprint includes only production and pre-production environments, but it can, of course, be customized. It also includes a list of groups to enable role segregation as recommended by the CIS, along with a collection of policies to manage your tenancy. In the network layer, we will recommend a hub and spoke architecture, and in the hub, we are going to deploy our hub model option A, our default model, which is ready to onboard 2 different firewalls. By the way, our native firewalls, one for the external traffic inspection, north-south, and the other one for the internal traffic, east-west. For the hub models, we have 2 options, one that includes the deployment of firewalls, and another often referred as a light options, which exclude the firewalls to reduce the cost during the testing phase. In this case, we will select the light option and we will deploy VMs to function as firewalls for the routing tests. Additional layers for enabling security service and observability are also included. For simplicity, we are presenting only IAM and network layers in this diagram. All resources defined in the 1OE will be included in our JSON files to be used as input in the orchestrator. Step 2 will extend the foundation landing zone, preparing everything for the Kubernetes cluster. In the IAM layer, we will create additional compartments, one for the OKE/Kubernetes production cluster and another one for the OKE pre-production cluster. As a best practice, we will also include a shared environment for management purposes, such as Argo CD or other CI/CD tools. We will add 3 groups, dynamic groups, and the required policies. Lastly, In the network layer, we will create the spokes VCNs, establishing isolated network for each environment. Note that all the network resources will be placed in the network compartments. After run the OKE Landing Zone Extension, we will have something like this. Let's zoom in on the network area. We can see that the routing enabled at this point is basic. We are missing the spoke attachments, the firewall routing, and the DRG routing. To enable full connectivity, we need to complete few additional steps. First, we need to deploy the firewalls. Second, we need to update the hub routing with the correct private IPs of the north-south and the east-west firewalls. At this point, also we can add the Kubernetes spoke attachments. And as the final step, we can update now the route tables of the subnets in the spokes with the DRG routing, now that the DRG is visible. All of these changes are included in our asset. Everything can be automated as post operations by simply updating the previous JSON files. Let's go and check our repo. This is our Open Entities Landing Zone repo. Here we have the repository structure with all the blueprints, the ONE multi-OE and the multi-tenancy. We have the add-ons and also the workload extensions. We can see another repository or related repositories as the orchestrator and the Terraform modules. Let's go to the workload extensions. We have different workload extensions like the AI for AI services, Business Suite, XSCC, OCBS, or OKE. Let's click in the OKE. This is the OKE Landing Zone Extension. We offer two flavors. The default flavor with 3 classes, one for production, another for pre-production, and the management environment. And also we have a simple option that it can be used for POCs with only one OKE class. Let's select the default option. Here you have all the documentation and you have all the steps that are needed in order to be ready to deploy your OKE. As we said at the beginning, you will need a foundation landing zone. It can be the open landing zone or the core landing zone. After that, you can proceed, and you can extend the landing zone with the OKE extension. Then everything will be ready to create the cluster itself. Let's go to check all the required steps to create the OKE extension. In this page, you have the description of all the resources that will be created. In the summary, you can see how you can deploy directly using Resource Manager both operations. The first step will be as a prerequisite to create the ONE. With this button, you can directly create a new stack to manage the deployment. You have all the steps here in this section. After that, when you have the foundation landing zone, as we said, we can go proceed, and with the next operation, we can extend the landing zone, and we are going to use these files, the configuration files for the OKE Landing Zone extension. In this page, also, you have the description of all the resources that will be created, like the compartment structure, like all the groups that we recommend, even how you can link these IAM groups with the OKE reback. You have also the dynamic groups that we recommend. In each section, you can see links to the official documentation, all the related policies that are needed, and the network configuration. You can configure a native pod network option that will include a pod subnet, or you can also configure a flanner configuration. Here you have a summary about all the different resources related to the network area that will be deployed. You have the VCNs, the subnets, the route tables, the security lists, and all the gateways. In some cases, you will need to make some changes in the JSON files. The recommendation is to use the dependencies module. Then in that case, you won't need to change nothing. Everything will be automated.
Then the next section, the deployment section. You can deploy everything with the resource manager, or you can use Terraform CLI. You can manage all the post operations to update the routing following these steps. And after that, everything will be ready to create the OKE cluster. Let's go to the console. If you have followed all the steps correctly, the outcome should look similar to this. This is the compartment structure. Here you have all the groups that will be created. Also the policies. And the network layer. If you go to the network visualizer, you can see all the different VCNs creating the hub and spoke architecture. This is the hub, and these are all the spokes, DRG and all the attachments. We have been creating everything using these two stacks. In Resource Manager stacks, we have the ONE stack and also the OKE Landing Zone Extension stacks. One tip here, remember to uncheck the run and apply option when you create the stack. You will be able to run first the plan, check in the logs all the resources that will be created, and after that, run the apply. You can see that we have run the plan and apply twice. The first to create the OKE extension itself, and the second one to extend the network with the DRG routing after we have attached the spokes to the hub. Let me show you also the bucket. This is the bucket. And these are all the files that we have been using as input for the two stacks, for the ONE deployment and also for the OKE Landing Zone extension. And that's all. If we click the apply, we can see here in the job resources all the different resources that will be attached to the stack itself. And that's all for now. Thank you so much for watching, and I hope you enjoy it. I'll see you in the next video. Take care.